Alright folks, so our goals for today, um, our goal is that you can predict the products of a neutralization reaction, and then after you predict the products that you can balance the reaction. So agenda for today, we're going to take notes on neutralization reactions. You're going to follow along with the examples where I predict the products of neutralization reactions and then balance the equation. And then you're going to get some practice predicting the products of neutralization reactions and then balancing the equation. Okay, so recall the general formula of an acid-base, or the other name for that is a neutralization reaction. So when I say neutralization reactions, I just mean when we're reacting an acid with a base. So the general formula is we've got this HNM, which is really just an acid, plus MOH, which is really just a base. Now what happens here is the H from the acid is going to switch places with the metal from the base, and so that's going to produce this. The metal will pair with the non-metal, and so this metal is going to move over here, pair with the non-metal. We call that a neutral ionic compound. And then the hydrogen is going to move over here and pair with the OH and make H2O, or water. So we've got our acid that reacts with the base to produce a neutral ionic compound and water. So in a neutralization reaction, the hydrogen from the acid switches places with the metal from the base. When this happens, a neutral ionic compound and water are formed as products. So remember, the things on this side of the equation are called products. All right, so recall that one hydrogen ion will react with one hydroxide ion to form one water molecule, and two hydrogen ions will react with two hydroxide ions to form two waters. So that's what's happening in these acid-base reactions, is hydrogen is reacting with hydroxide to make water. And that kind of happens in every single reaction. If you have twice as much hydrogen and twice as much hydroxide, you're going to make twice as many waters. And same thing if you have 3 hydrogens and 3 hydroxides, you're going to make 3 waters. If the acid has fewer hydrogen ions than the number of hydroxide ions in the base, so if we're dealing with one of those acids with more than one hydrogen ion, if you're dealing with one of those bases with more than one hydroxide ion, then more acid compounds will react with the base. If the acid has more hydrogen ions than the number of hydroxide ions in the base, so now if the acid has more H's than the base has OH's, then more base compounds will react with the acid. Finally, recall that the total number of each type of element must be the same on both sides of the equation. That's called the law of conservation of mass. We can't create or destroy matter in a chemical reaction, so there's got to be the same number of each type of element on each side of the equation. Okay, so examples of neutralization reactions. So here we've got HBr reacting with KOH. Again, the H. Okay, so that looks better. So the hydrogen is going to be trading places with the potassium. So when that happens, we're going to have potassium bromide, so KBr, and then our second product is water, HOH. If you want to write it as H2O, that's fine. I'm going to write it as H2A, HOH for this one, just to show what's switching. Okay, and then because we have one hydrogen on the left, in the acid, and one hydroxide in the base, we're just going to produce one water. Okay, so now let's take a look at the second reaction. Again, the hydrogen is going to switch place with the metal. In this case, that's beryllium. So we're going to get beryllium carbonate, so BeCO3. All this CO3 stays together. And then we're going to get HOH for our second product. But for this one, because we have 2 hydrogens and 2 hydroxides on this side, that means we're going to produce 2 waters. So hopefully that makes sense. Pretty straightforward so far. This next one's going to get a little bit more complicated. So the first thing I want to say is that we need 3 hydrogen fluorides for this reaction. And that's because, look, we have 1 hydrogen here and 3 hydroxides. So those can't fully react because there's only 1 hydrogen to pair up with the hydroxides. We need 3 hydrogens. So we're going to add 3 of these hydrogen fluoride molecules. And if you want to know why we had 3, it's because there was 3 hydroxides and only 1 hydrogen. Okay, so now the hydrogen and the aluminum are going to trade places. So we're going to end up with aluminum trifluoride and water, HOH. So again, there needs to be 3 fluorines in this formula because we had 3 hydrogen fluoride molecules, and that means that there's 3 fluorines on this side. It will only be balanced then if we make it so that there's 3 fluorine molecules. And then because we had 3 hydrogens and 3 hydroxides, that's going to give us 3 HOH molecules in our products here. So this is kind of what the final answer for number 2 looks like. We're going to have 3 hydrogen fluoride molecules react with aluminum hydroxide to produce aluminum fluoride and 3 waters. Okay, so now for this one we have 2 hydrogens in the acid, but we only have 1 OH in the base, only 1 hydroxide. So we're going to need 2 base molecules to react with this acid. So that's why I'm putting a 2 here, so that we can have 2 OHs to react with those 2 hydrogens. Next, I'm going to switch places with the hydrogen and the lithium. So that's going to produce lithium 2. That's going to produce lithium oxalate. So again, this 2 is coming from the fact that we had 2 lithiums over here, right? So those lithiums need to balance. And then if we count, we have 2 hydrogens here, 2 hydroxides here. That means we're going to produce 2 waters. Okay, in our last example, we have phosphoric acid, and that's going to react with magnesium hydroxide. And so I put a 2 in front of here and a 3 in front of here. Now, the reason why I do that is if you look, we have 3 hydrogens on this side and 2 hydroxides on this side. And so I'm doing that because 2 times 3 equals 6. So now I have 6 hydrogen atoms, and 3 times 2 equals 6. Now I have 6 hydroxide atoms. Right? So really I'm putting a 3 here, and I'm putting this 2 over here. So now we have the same number of hydrogens and hydroxides. Now I'm going to switch place with hydrogen and magnesium. So these are my products. Again, I need 3 magnesiums in my ionic compound because of this 3 that was out front. I need 2 phosphates in my neutral ionic compound because of this 2 that was out front. All right, and this is just to balance. Okay, and again, there's 6 hydrogens on this side. There's 6 hydroxides on this side. 6 hydrogens and 6 hydroxides will produce 6 waters. Hopefully this makes sense. Give it a try with some of the acid and base reactions here. Some of these neutralization reactions. Try and predict the products and balance the equations. We'll go over this as a class tomorrow.